So, good afternoon. Good afternoon, Dorin, Prunariu. Good afternoon, you all. I am very pleased to welcome Dorin Prunariu today. He is a special guest. He is a Romanian cosmonaut. And in 1981, he flew into space aboard the Soyuz 40 spacecraft to the Soyuz 6 laboratory. There he and his crew conducted experiments in the fields of biology, medicine, and physics. And after his flight, he was a founding member of the Association of Space Explorers. And he was also elected for a 3-year term as president of this association. He has been the permanent representative of the Association of Space Explorers at the UN, United Nations Committee on the Peaceful Use of Outer Space, in short, COPUS sessions. He was elected chairman for this session in 2004 and held this position until 2012. Then, between 1998 and 2004, he was the president of the Romanian Space Agency. From 2004 to 2005, he was the Romanian ambassador to Russia. And he also became declared the first official Asteroid Day ambassador for his engagement in raising public awareness about the asteroid impact hazard. Also, he has received several high-ranking awards. One is the Social Science Award of the International Academy of Astronautics. And before I let Dorin speak, I personally have to thank him for his ongoing engagement to the teaching activities at the TU Vienna. Because besides his deep knowledge in space technology and space politics, he has a wonderful way to communicate his engagement for the sustainable and safe development of space activities. Thank you, Dorin, for joining us today and for sharing your unique experiences. Welcome, and the floor is yours.
Thank you, Sandra. It's a pleasure for me to be in touch with you, with your students. It's not the first time. Till now, we did it live in Vienna. Unfortunately, now the conditions don't allow us to be present in the same environment physically. So I have to do lectures from my computer. And I do it pretty often. I do it with schools, not only in Romania and abroad. Just 1 week ago, I had a lesson for some children from Pakistan. And I have from Luxembourg and from many other places. So as long as you are students in an architecture faculty, I think it's interesting for you how it's into the outer space, how it's inside a space station, how it's inside the habitable place, how people live there and how they work. Just to show you all these things, I will make a PowerPoint presentation. I will share the screen with you. I will tell you a lot of things connected with living and working into the outer space. And then we continue with questions and answers, with discussions, and I will be very glad to listen to your opinions and questions and to answer them. Well, share screen, 1 moment. So I think you see my screen, yes? It's okay, yes? Okay, from many years, we fly into the outer space to find out more about the life on Earth. We don't know exactly what is the origin of life on Earth. We don't know exactly how it's to live outside Earth. We don't know a lot of things. For that reason, we started to fly into the outer space. We started to fly on other celestial bodies. Till now, we touch with people only the moon. Moon is not so far from the Earth. Apollo spacecrafts flew to the moon for about 5 days, stay on the moon several hours, days, and then came back. But the most important thing for the last more than 20 years is to live and work on board the International Space Station. Of course, till the International Space Station, there were a lot of other space stations like Soyuz from 1 to 6. On Soyuz 6, I flew into space 39 years ago, more than 39 years ago. Then Salyut 7 and Mir. Mir became an international space station. The space shuttle docked with Mir, and American astronauts, together with some other international astronauts, had the opportunity to work on board Mir space station. And then from 20 years, the International Space Station is permanently occupied by astronauts and cosmonauts. So a few facts and numbers about the International Space Stations. The living and working space in the station is larger than a 6-bedroom house, six sleeping quarters, 2 bedrooms, a gym, and 35 degrees view by bay windows. So you can watch anything outside the space station from many modules it has. So it orbits the Earth at an altitude of about 400 kilometers. It could be 420, 350. Sometimes the space station maneuvers into the outer space, mainly for avoiding the collision with space debris. The speed of the space station around the Earth, it's about 28,000 kilometers per hour, and the full orbit around the Earth, it's done in about 90 minutes. The solar array wingspan of the space station, it's huge. You see, it's here in feet because the facts are taken from the US. It's 240 feet. It's about the same length as the world's largest passenger aircraft, the Airbus 380. So it has a length of about 100 meters from end to end. And it's like a football court, football field. So the on-orbit software and monitors have approximately 350,000 sensors, ensuring station and crew health and safety. 6 spaceships can be connected to the space station at once. Okay, let's see how to start and how to fly to the International Space Station. So I choose a Soyuz spacecraft because till now, this is the most usual spacecraft that take astronauts and cosmonauts to the International Space Station. But we have to take into account also the SpaceX new Dragon space crew, who last in November 14 took to the space 4 astronauts. One of them, it's a Japanese astronaut, Soichi Noguchi, also a good friend of us. But inside the Soyuz spacecraft, the space, it's very limited. You have on the left side an image of the 3 astronauts sitting inside module, the command module of Soyuz. The lower image is with a wide angle objective taken, and you see them very squeezed in front of the board. You have the image of Soyuz spacecraft flying into the outer space, launched by the Soyuz rocket, and the launch is on the right lower side. How it's inside the Soyuz spacecraft. You see only 1 astronaut, and you see the wide angle image. Actually, it's very, very narrow inside. And you see a board with a lot of switches, a lot of touches with 2 big screens. I can assure you that the new SpaceX spacecraft, it's wider. It has a very few thumbnails and switches inside. and has only touch screens. It's like from the architectural point of view, it's much more easier to stay and fly with a SpaceX capsule now. Look how it looks, the space station now. It has 8 modules. One of them it's European, it's Columbus module. One of them it's Kibo, is the Japanese module. And the rest, they are Russian and American modules. Inside the ISS, it's a huge space, long corridors, but full with equipment. See, it's a full mess inside sometimes. And cosmonauts and astronauts work in different modules in accordance with the scientific program they have. Look them inside. It's a module more or less occupied by equipment. You know, now on board the ISS, there are 7 people. 4 people from the mission 64 launched in October, and 3 others launched in November with the private SpaceX spacecraft. 7 people could work easily on board the ISS, but the space is for much more people. As I said, the space station could dock with 6 spacecrafts, but never so many spacecrafts flew in the same time into the outer space. A big problem is the launch rockets and the spacecrafts, because the Soyuz ones, according to the production line, testing facilities and so on, they can fly 4 times a year. So no more than 4 launches with Soyuz spacecrafts could fly into the space. And now with Dragon spacecraft, 4 astronauts could fly at once. Maybe the accelerated way and more astronauts will dock to the International Space Station and work in the same time. You see, there are a lot of scientific modules inside the spacecraft. You see one of the modules inside, they are done a lot of experiments with different very sensitive materials. You have gloves, you stick inside that module your hands and work with different materials. At the same time, now on board the International Space Station, it's a 3D printer, and you may print a lot of things, including spare parts for the International Space Stations. The testing of the 3D printers is very necessary, because when you fly to the moon and to Mars, you don't have the opportunity to take spare parts from the Earth. You take a very few ones, but you have to produce in place, inside, a lot of things you need. If you know, I can tell you. If you don't know, including food that is proposed to be printed, so printed now with such 3D printers, special 3D printers for food. You know, being in the outer space, besides the experiments, you have to live normally. As in weightlessness, you don't move so much. You don't have to carry your own body. You don't make too much effort. Taking into account that the muscles and the bones are sustained in a good shape and strong just by moving, weight-bearing exercises, you have to do it out. They are produced special shoes. You see in the image a special shoe that measure your weight-bearing exercises, how much you have to make to be and to keep in shape. So these shoes have special sensors, and they measure the pressure on them in such a way that can measure how much you exercise into the outer space. into the outer space for not only for food, but also for producing oxygen in the future interplanetary flights, you grow plants. You see some laboratories here, some astronauts growing plants, following them, measuring the oxygen product by these plants, and of course, consuming the CO2. And also into the outer space, besides many experiments, uh, most of the astronauts teach students, have lessons for students from the outer space. See a place where Tim Peake, the British astronauts, teach students about a lot of physical things produced into the outer space differently than from the Earth, and also some other astronauts teaching them how to eat, how to sleep, how to live into the outer space in very special conditions. So, space food. You have to eat into space. Look, Scott Kelly, an astronaut who spent 1 year into the outer space, how they test a lot of veggies for food, and how it's the effect, the beneficial effect of the plants on the body, including into the outer space. Some other astronauts eat fresh food. Sometimes the cargo ships bring them to space fresh food like fruits, vegetables, and they have to eat them to maintain the body in the good shape. Look, when Luca Parmitano and when other Italian astronauts were on board, they eat pizza. So you have an image on the right upper side with me on board the Salyut 6 space station, eating together with the main crew. We had small boxes, tubes, and so on with food. Usually when it's the international crew on board the ISS, they gather together during the lunch, eat together, socialize, because otherwise each of them, they stay in their modules doing experiments and working very hard. You see in the lower side, Luca Parmitano with some Italian products, salami and so on. And you see a Japanese astronaut on the right side eating with sticks. How do we drink water into the outer space? So drinking water, it is a problem because you don't have the water in the same, you don't use the water in the same environment where the gravitation acts on the water. So you have to drink it from tubes, from different recipients, but don't leave the water outside in the atmosphere of the space station, because they could affect the equipment, electronic equipment, break them, and so on. So how do we wash into the outer space? We have to wash, as normally on the ground. You see on the right lower side, a Canadian astronaut showing you that the water doesn't pour. Even if you squeeze a towel with water, it stays on the towel. So it's quite impossible to collect the water other ways that with towels, with cotton dress, and to put them in special boxes where you close them completely. Samantha Cristoforetti is washing the teeth inside the space station, but it's a special toothpaste that you can eat if you want. You have showers inside the space station. They are not very often used because it's pretty difficult to stay inside the shower and to breathe through a mask the air from outside, because otherwise you can breathe the water from inside and have big healthy problems. You have to wash the hair. Look, the astronauts washing the hair inside the space station. In the same time, when you stay long into the outer space, you have to cut the hair. You see, there is a special machine to cut the hair, but it has in the same time a vacuum cleaner that takes all small hair that you cut with the machine and don't leave them in the atmosphere because they could cause problems to the astronauts. So how do we make sport? How do we exercise? So I showed you previously how do we exercise. You have a treadmill here where the astronauts exercise, and you have an image taken by me on board Soyuz 6 space station with 2 colleagues. I flew into the outer space. So we have to sleep as well into the outer space. We have to maintain our biological rhythm, the 24 hours biological rhythm we have on the ground. So for about 8 hours, we sleep into space, 8 to 12 hours, we work into the outer space, and we have from 4 to 8 hours, it depends of the work we have done, free time for administrative things or for watching the Earth from the outer space. So on the leftover side, it's me with 2 of my colleagues from Salyut 6, sleeping in sleeping bags. Now the astronauts have special places to sleep inside the space station, or they could sleep, as you see on the right left side, or right down side, also in sleeping bags, very well tied on the walls on the space station. You have to go to the toilet. There is a special toilet inside the space station. See how it looks. You have to fix the hands and the legs on that to sit on the toilet. It works on the principle of vacuum, and it takes all the products you have, the urine and the hard things, inside the special cans that could be closed after. After you work and live into the outer space, you have to come back to Earth. Some astronauts live in space for 1 week, 10 days, half a year, or even 1 year. You see usually how is the orbit, the red one on the upper left side, the orbit of the spacecraft after undocking from the International Space Station. So it usually has an inclination against the equator of 56 degrees, because this is the orbit of the International Space Station. It undocks, turn the engine in front of it, turn the engine on, brakes, and you have the image of the landing module. Of course, it's not a real image, it's an imitation. How it comes into the atmosphere with the astronauts sitting on their backs. So as during the launching, during the landing as well, you are facing about 4 Gs. You are pressed in the chairs of the spacecraft, and for about 10 minutes during the landing, you face about 4 Gs. It's not so easy, but you are trained to do it. How it looks, the landing module after the landing, and the big parachute that takes it back to the Earth. Usually you have to land in a vertical position, but if you have a wind during the landing, so you are supposed to not land perfectly vertically, and you have not very soft landing, but you have to face it and you are trained to do it. So now we're in front of a new program. We will not fly not only on the International Space Station, we'll continue to fly the International Space Station. It's guaranteed for flying, an agreement between the countries taking part in International Space Station exploration and exploitation. It's signed till 2030. But in 2024, the Americans, in the framework of the Artemis program, the new American program for the exploration of the moon, are supposed to take to the moon a new crew formed by one woman and next man because already 12 men landed on the moon and stepped on the moon in the framework of the Apollo program. The new Orion spacecraft will fly to the moon. The service module of Orion, it's built by Europe, by the European Space Agency. And around the moon will move an international space station, the Getaway Space Station. Why international and not American? Because besides the US, JAXA, the Japanese Space Agency, and ESA will build also modules. ESA will build two modules, one in cooperation with JAXA and one alone, to be attached to the Getaway Space Station. From Getaway, a special landing module for the moon will be built by private companies. Blue Origin, it's one of them. Blue Origin, it's the property of Jeff Bezos, one of the richest persons on the earth, and he has a very developed space program, besides Elon Musk, who has also. You see an image of a future moon base. The future moon base will be built on the south pole of the moon. Why the south pole? Because there you have quite permanently sunlight, and at the same time you have the most quantity of water in the form of ice and oxygen in the form of oxides that could be used for producing oxygen on the moon. And next step, it's Mars. Of course, the moon program will prepare the flight for Mars. The experience of the moon program, the experience of base built on another celestial body will lay the opportunities for flying farther, much farther to Mars. Mars in the best position against the Earth, it's at a distance of 65, 70 million kilometers, not only 380,000 as is the moon. A flight to Mars takes about 7 months, another a few months of working on the planet with a gravity of 2.5 times less than on the ground, and then another 7 months to come back to the Earth. It's a quite challenging experience, and the crews have to face different new, unknown till now situations, including the flight in the interplanetary space, where the space radiation is higher, and you have to spend times in a small spacecraft, socialize in the same time to understand each other's, the members of the crew. It's a big challenge from psychological, social, and scientific point of view. Okay, that was my presentation. I will stop sharing, and now we can speak about anything you want connected with the outer space, with space flights and space exploration. So I see one questions, the most memorable moment during my space flight. You know, from my point of view, it was very pity that I had the opportunity to fly only one time into the outer space. I was very well prepared. I was chosen between two very good results during my training. And I really enjoyed my time was day before the launch, because I had all bad things that happened till now into the outer space. I had time to think about the accidents, catastrophes that already happened into the outer space. Not all of them till my space flight, but some of them. So
Elizabeth.
But when I was launched into the outer space, I had no more time. I had no more time to think about such things. And I have to accomplish my full scientific program. I have to deal with the space maneuvers, with the docking with the International Space Station, then with the undocking. I can tell you the most memorable time was when I looked down to the Earth. The image of the Earth, it's impressing from the outer space. And also it's very impressing, the thinnest of the atmosphere. You see the atmosphere as thin as the core, sorry, as the core of an apple, if you compare the Earth with an apple. It's very thin. In the same time, you think that all life, all the oxygen on Earth used by beings, by humans, by plants, it's in that very thin atmosphere that is very much polluted now. So that was a very impressive moment of me looking at the Earth from the outer space. Otherwise, the life in weightlessness, it caused a lot of problems in the beginning, the transformation in the body. You have to face different transformations, and they are not very good as feelings when you fly into space. But when you accommodate to the weightlessness, everything is easy, you float, you feel very light. But you have to face the opposite situation when you come back to the Earth, when you feel maybe in the first hours twice as heavier as you was before. Okay, let's take some other questions.
Elizabeth.
Yes.
You may read them if you have them in front of you.
Would you like to have another question?
No, it was just the most memorable moment. I thought it's
Okay.
no.
Next is Eric. Eric, maybe ask your question.
Yes, I do it. Thank you. My question is, how long does it take astronauts to get used to gravity again after a long mission in space? So the environment and something like that.
Yes. It depends very much on the exercise you do into the outer space. It's mandatory to do a lot of exercises, but in the same time, I can tell you that after 1 week spent into the outer space, was my case, it took about 2 hours to accommodate to the gravitation and just to stand vertically. Because in the very beginning, you can't stand. You have the impression that everything turns around you. You can't keep your position. And you are helped by other people from beside you that keep you vertically if you just want to stand and sign and give interviews and so on. But then I can tell you that after about 2 hours, I had the real feeling of the gravity acting normally on me. But next day, I feel some modifications on my muscles and bones. And even 10 days after my space flight, after I landed, I had some pains in the spine. So it was the process of reaccommodation. Usually it's said that the process of complete reaccommodation to the Earth conditions takes as long as you spend into the outer space. Of course, the first days, they are more difficult if you spend half a year or 1 year into the outer space, but also inside the body, you don't feel death. A lot of processes are still coming back to the normal after the space flight.
Thank you. Very interesting.
Welcome. So, anything else?
Anna, would you like to talk, to pose your question? I cannot hear you. Yeah, very little. Can you turn the volume on? Okay, just come closer to
If you want, I can go on the chat and see there if they brought some questions.
Okay, try Anna.
Anna. Anna Dumitru, she's a Romanian one. Oh, I don't listen, but I see the questions. I would like to ask, what, in my opinion, the biggest difference in the process of preparing for the mission then nowadays is, and also what is the most surprising research outcome for you? Personally, I would also be interested in how well the educational programs in Romania are for upcoming cosmonauts. Mulțumesc. Ok, Ana. O să-ți răspund normal în engleză ca să înțeleagă toată lumea. I will answer in English to be understandable for everybody. For how long are you in Austria? Or you are established permanently there? Ah, you are born in Austria. Because I don't listen to anything. You have the microphone off. But if you listen to me, it's okay. Okay. So there is not a big difference in the preparation of the astronauts and cosmonauts. There is not a big difference because the conditions into the outer space, the action of the weightlessness on the body of the human body is the same. So actually now there are more different activities on board the International Space Station. After you graduate from the general course for becoming an astronaut or a cosmonaut, it could take about 2 years. You are prepared for a specific space flight, a long space flight or a short space flight. There are differences in training, there are differences in approaching, there are differences in the scientific outcome. You have to learn a lot of things about science of the experiments you accomplish into the outer space. But from physical point of view, is the same thing as I did 40 years ago, the astronauts do now. Of course, the space medicine is developing anytime, and they bring some new type of exercises you do, more efficient sometimes. And at the same time, you have more sophisticated equipment for measuring a lot of medical parameters into the outer space and on the ground before flying and after flying into the outer space. Everything is now much more miniaturized, digitalized, comparing with what I had during my space flight. What is the most surprising research? Maybe growing plants is one thing because it's surprising how they grow into the outer space. On the ground, they use gravity for the roots to get inside the earth, and they use sun and light to orient themselves to the sun. Inside the space station, you don't have the sun. You don't put them in front of the window anytime. And it's interesting to see how they grow following the closest light they have next to them. You just have a light, and you put the plants with all the systems to grow against that fictional axis of the gravity and light. At the same time, it's very interesting to raise different small animals. Mice, there are different experiments on mice into the outer space to see how the reproduction system works into the outer space, because we have to know much more about how the reproduction system of the humans will work in the future into the outer space. Because if you fly for years and years on Mars, by instance, you have to live as a normal family. The family will form on the planet. They have to give birth to children. And for now, it's not very well known if the reproduction system in weightlessness is functioning as normal as on the ground. Yeah, there were no human experiments because, you know, into the outer space, you are looking also for ethical problems. And it's not ethical just to send two persons, a woman and a man, which are not married or which are not in a relations, and to have to make experiments from this point of view. For now, it's just understudy with small mice. But at the same time, you go frogs. Frogs, they study how the vestibulary apparatus works and how the balance of the frog in weightlessness goes on comparing with the Earth. And at the same time, some small frogs were taken back to the Earth, and they lost for a period of time the possibility to feel the gravity and to move in a balanced way. They just jump and they fall down, not taking into account the gravity. Also, they were experienced with eggs and chickens, small chickens inside the space station. You see, there are a lot of very interesting things they do now in the International Space Station. Also, there are a lot of experiments, even production of some materials, because into the outer space, you can grow crystals and different materials in a very pure way, because the impurities are distributed uniformly inside the materials you grow there, because they are not affected by the gravitation. Also, they are produced very pure materials for pharmaceutical purposes, and very efficient materials also for pharmaceutical purposes. Now, the outer space is not used only from the point of view of the governments. Also, a lot of private experiments are done, ordered by private company, paid for by private companies, and they are done by NASA astronauts, mainly for the American ones. In the future, they are already selected commercial astronauts. And with SpaceX will fly soon commercial astronauts. They are hired by different companies to do experiments or to make a production for them into the outer space. So there are many other problems, but I think some good images of what could be done into the outer space now you may have by my explanations. Okay, Anna. Good health. Sănătate și salutări de Ziua Națională a României. Oh, today is the National Day of Romania here in Romania. So in the morning I watch on TV the parade and the activities done with this occasion.
All the best.
Okay.
We have two more from the students. Is it Christina? We have two questions from YouTube.
So I see, when did you decide that you want to be an astronaut, and how did you achieve it? And what did you miss the most when you were in outer space from C. Traub? I see on the chat, it's a question. I take them from chat, or you want to select some of them and read them?
No, I think it's okay. When did you decide that you want to? I think it's a nice question. I don't know where you.
Yes, because, you know, even some of you could become an astronaut in the end. When I was a little child, I liked very much to know things about flying into the atmosphere, and I wanted to become a pilot. Then when I grew up, I wanted to know how the airplanes are built and how is the construction of an airplane. And then I decided to follow the courses of the Aerospace Engineering faculty at the Polytechnica University in Bucharest. I graduated in 1976, but in the same time, I had the opportunity to fly in the air club as a pilot, as a sport pilot. At that time, I never thought that I could become an astronaut. It looked for me very far from Romania, very far from my own possibilities. But Romania took part in the Intercosmos program. It joined in 1968. We didn't know, so we didn't read about that. We were focused on the aviation, building airplanes and so on. But when I accomplished my military service, the mandatory military service, the commander of the space unit came and asked all the young engineers then accomplishing their military service, who wants to become a volunteer for a space flight. We were amazed. We couldn't believe that we are asked for such things. And he said, who wants to raise the hand, and he will pass some medical tests, special medical test in Bucharest. So I said, why not? Why to not pass some medical tests? I raised the hand. I said, yes. In the same time, my wife was a student in Bucharest, and I said, with this occasion, I go and to see my wife for a week. But I was not very sure that I will be selected for full training as a candidate cosmonauts. But after all the medical tests, I was one of the very few selected, and I said yes. Then I had the opportunity to learn more about the outer space. We were taught about the outer space, about the space flight, orbits, space environment, and so on. And I really like it. And I decided to change my profession and to follow this path. Then Star City, 3 years of training in Star City, being selected to be the first Romanian into the outer space. And from that time, my career completely changed, because it was not anymore focused on the aviation, but most of the space. Even if after my space flight in 90s, I became the head of the civil aviation department in Romania. In the same time, I represented Romania in international organizations dealing with space, and I continue to work with my scientific fellows that did experiments with outer space and continue the Romanian space program. What I did miss most when I was into the outer space, I was for about 8 days minus 4 hours. Not too long, but I miss the communication with my family. I always used to stay in touch with them in Star City. We live together. I live there with all my family. I have 2 small kids, 2 sons. One was 3 years old, one was 5 years old. I used to speak, to play with them every evening when I came back from my work for my training. And 2 weeks before my space flight, I lived in Baikonur, far from my family, another week into the outer space and another few days after my space flight. And I really missed them. I missed to speak with my kids. I missed to stay with them, answer different questions. But in the same time, I took 2 pictures with them into the outer space. I stamped them with a special stamp existing on board the International Station, Salyut 6 at that time, and I keep them as a souvenir from the outer space. At that time, it was quite impossible to have phone calls from the space station with the family. They organized special sessions with the families of the astronauts that stay longer, 1 month, 6 months into the outer space. The families came to the command center in Moscow, and they talk by using the communication system of the space stations. Now, in our days, you may have phone calls from the board of the International Space Station. You have internet on board. You can see your emails, answer the emails of your friends, your family, quite any time when you have time. It's different now than at that time. So from Alma Kugik, it is possible to produce any kind of artificial gravity, and what would be the benefits for physical and mental health? And is it possible to introduce more plants into the interior? Okay, speaking about plants, it's possible to introduce more plants, but all these plants have their special places in the interior of the space station. You have special places for different type of experiments. You don't grow plants and you grow them in-house at home. But it's possible if you really need, especially for scientific experiments. It's possible to produce gravity, but you have to have big spacecraft turning around an axis inside into the outer space, like a Thor. It's possible to produce it, but not on board the International Space Station. You have to fly on special stations that may turn around an axis, and they produce acceleration inside, which looks like the gravity. If you fly to Mars, or even farther, if you fly very long times, it's feasible and it's recommended to have the lowest gravity inside the spacecraft and not only the weightlessness. Because when you have even a very low gravity, the processes inside the body, they are more facile to accommodate to the space flight. Now the astronauts are testing, or not now, during the flights to the moon and on the moon, they are testing the influence of the low gravity. On the moon, it's 6 times less gravity than on the ground, and on Mars is 2.5 times less the gravity. And it's very interesting to study the processes in the body in low gravity, not only in weightlessness. For now, we know what happened in 1 year when you fly into the outer space in weightlessness. But for sure, the processes are a little bit different and more easier to accommodate with the astronauts in low gravity environments.
My question was about also, is it possible to somehow make gravity, but in this case, to try to maintain normal position of the body somehow?
For sure, if you have the lowest gravity into the outer space, you stay vertically with the feet to the direction of the gravity. For sure, you can have this position, and it's recommended to have this position as you have it on the ground.
Mm-hmm. Okay, that was.
You see a lot of movies, science fiction movies. Now the simulation of the weightlessness in movies is done very easy with the help of computers. And you see when it's slowest gravity, when the big, huge spaceship turns around an axis, they stay with the legs on that direction, like on the wall, on the ground.
Mm-hmm. Thank you.
Okay, welcome.
Dorin, we have 2 questions via YouTube. One is by Kavada. Have you ever experienced any bad or...
Yes, I see by Kaftar.
And the other one is by...
Yes, I see if I had experienced any bad or complicated situation in the space. You know, till now, I notice, speaking with my astronauts fellows, reading a lot of materials, that no spacecraft and no space flight, it's perfect. Anytime it happens to appear different situations, more or less complicated. So we had, I may say, 2 less complicated situations where we were fortunate. After arriving in weightlessness into the outer space, we were obliged to test all equipment we had on board. All equipment used in normal situations, in normal flight, or used for coming back to the Earth in special situations. We had some automatic space programs on board. So we had electromechanical computers at that time that just accomplished their job and could bring us back to the Earth. One of the equipment measured the direction of the space flights and the position against the axis of the orbit. It measured the ions of the space environment and could make a difference if the position of the spacecraft is not exactly on the direction of the flight. So we could turn the spacecraft around the axis, turn it as we wished. But that equipment just oriented the spacecraft when the two sensors have the same amount of ions coming on them. They are inclined at 45 degrees. And that equipment didn't work. So it caused problems because we had to change the procedure of oriented the spacecraft in the, any complicated situations and have information from some other equipment. We could gather information from some other equipment, but to combine them and to make some calculations to have the right information on board the spacecrafts. It was one of the problems, but in the end, our space flight was normal, didn't have the special situations, and we were not obliged to land in a complicated situation, but in a normal situation, and we didn't use that equipment. The second more complicated situation was during our landing, because you know, after you enter the atmosphere under a very small angle, 1-2 degrees, your spaceship starts to heat. All the energy, the kinetic energy you have flying with a speed of 28,000 kilometers per hour around the Earth is transformed in thermic energy by framing the spacecraft into the atmosphere. And the temperature at the exterior, it's about 1,700 degrees, the temperature of the spacecraft. Inside, you don't feel this heat. Inside, you feel just the G's and you feel the vibrations of the spacecraft, and you feel when the parachute is opening. Well, you have some special signs when the parachute starts to open, and you know that after the top of the parachute container, it's ejected. You have 16.5 seconds till the main parachute is open. Our parachute had, I think, had some small problems, small maybe, bigger problems, and it opened a little bit later. We stayed with the chronometer in hand. We see 6.5, 17, 18, 19 seconds. We were in the radio communication with the command center near Moscow. And after the 17, 18 seconds, we just didn't listen anything. There was a full silence, and they just looked for what will happen with our parachute. If it didn't open, of course, in a few minutes, we'll make a big hole in the ground and we'll die, of course. If it opens, we are saved. And in the end, it opens when we heard from the command centers, Yura, they are saved, Yura, they are saved. And then we really understood that the situation was really bad, and they really followed a big concern, how do we land? And we landed. So that were the complicated situations. We are well prepared and we are ready to face any complicated situations, but anything that just depended on us. The landing didn't depend on us. The landing is automatically done, and we can't do anything.
So I have a question.
Yes.
Concerning plants and the airflow in outer space. So you've mentioned then the plants can also provide food, but also oxygen. And I'm wondering how the system for fresh air works in outer space, since you can just ventilate by opening a window. And
Yes, yes,
it
yes.
gets cleaned and naturated, or just sent up with tubes or in bottles. And how it will work on Mars, where the distances are far greater.
Yes, first, the plants on the International Space Station, they are used just on the experimental way. So they produce a very low quantity of oxygen, and you can't lay only on the plants to transform the carbon dioxide in oxygen. But on board any spacecraft and International Space Station now, you have special devices with special substances, chemical substances inside that absorb the carbon from the carbon dioxide and let the oxygen get out and be recycled. So we have we used on board Salyut 6 some lithium hydrates substances in some big containers, and the ventilator just push the air, forcing the air to be recycled through these tubes. And inside these tubes, the carbon dioxide was transforming carbon accumulated by that chemical substance and the oxygen that was released and breathed by us. In the same time, we have some special filters for different substances, smells, and so on. And the air is very well controlled on board the International Space Station. But in the same time, you have to recycle the air inside the space station all the time, forced by ventilators. Because of the weightlessness, the hot air and cold air don't mix them if you don't force them to mix. Also, the carbon dioxide around your body, around your nose and mouth, they don't mix with the air if you don't force them to mix, as it is done normally on the ground when the gravity mixes them in a normal way. So you have any time to use ventilators and to ventilate the air inside to mix them in the forced way. Okay. Any other aspect of the question, or you are happy with the answer?
Yeah, it was a great answer. Thank you. So does it ever break down, the machine?
Okay, welcome. Of what machine? For replacing, making oxygen?
Yeah.
Oh, you know, especially for ensuring the life system on board the space station, all the systems, they are doubled. If something fails, you have a reserve system, it starts to work and continue to work. And you have also the possibility to fix a lot of systems. The astronauts, cosmonauts are trained to fix the systems, to change some spare parts and so on. Anytime you have a spare system that starts to work when something happens. Of course, it's very difficult when you have a fire on board. When you have a fire on board, it happens. It happens sometimes. You have different substances to stop with a fire, like the fire workers have on the ground. But in the same time, you have to understand that the fire consumes a lot of oxygen from inside. And you have some reserves under pressure of air, and you have to replace part of the air, not only to change the carbon dioxide and oxygen and to make all this to replace some air with air from special balloons. They are under pressure sometimes 300 atmospheres, even more. Desermatization is also a problem on board the space station. if a desermatization happens and you don't find very quick the place where from the air it's throughout from the air space station, you have to fly very quick in your spacecraft, take the spacesuit, and to stay there and to come back to the Earth. Maybe you may lose the space station if the desermatization is very fast. But if it's very slow and it happens, even not far ago, if it's very slow, you may determine where is the place of desermatization. You close different modules and you see, you have sensors anywhere, pressure sensors, and you see in what module the pressure sensor still is active. And then you also may leave small drops of things and see where the air it's conducting all these small things floating into the atmosphere. And you go there, you go under the equipment and you reach the wall of the space station and you see where is the hole. Sometimes the holes are small sometimes. The cause could be a micrometeorite, space debris, or who knows, maybe from the construction of the space stations could happen some bad things from this point of view. The difference of the pressure between the space station and the vacuum, the outer space, it's 1 atmosphere. It's not very much. 1 atmosphere, you can put the chewing gum there and to stop the desermatization. So I see...
We have a question by Katja. Katja, do you want to ask it yourself?
Okay.
We cannot hear you. Okay, we have...
So I see another questions here. How important would you say is the interior assembly and aesthetics of the spaceship for future long-term missions? And maybe in comparison, the ability of Salute back in the days. Oh, I may tell you that during my space flight of Salute, even Salute 7 and Mir, they didn't look very much to the aesthetics and to have a very nice interior. They look just for be very efficient from the point of view of experiments, to have a place where to sleep, even you were surrounded by a lot of equipment. Now on board the space station, the International Space Station, they look much more to the aesthetics of the interior. A lot of equipment, it's miniaturized and it's put under the walls of the space station. And you have modules where more or less you like to look inside. But I can tell you that Elon Musk, it's looking much more to the aesthetic of the interior of its own spacecrafts and on the future spacecrafts that will take people to Moon and to Mars. If you look, you might find on Google pictures with the Dragon spacecraft. It's much more different than any Soyuz spacecraft. The interior, you can breathe inside. You have some white walls inside. It's very relaxing to look around. You have only the touch screens in front of you, like a TV at home. There are 4 for each astronaut. And the space, it's much more relaxed and more aesthetics than at the International Space Station. Of course, you had projects. Sandra wrote a book about the interior of the space stations, and I even contribute with some information and pictures on that book. It becomes more and more important for the astronauts, especially for the astronauts that live long time into the outer space, to have a nice environment, to have the things organized, to relax the eyes and be relaxed when you look around, not only being stressed by the huge equipment and the wires around. They have to look at these aspects of the space flight when they will construct the next spaceships, space stations, and Moon and Mars bases in the future.
Can you hear me now? I would have another question.
Yes, yes.
Okay. I thought about
Yes.
what ethical and social issues do you think might be associated with the possible settlements on Mars? And how did your experience in space change your imagination about this?
So I have quite an experience into the outer space because I spent there quite 8 days, and I had the feeling that I changed as a human being. I changed because I was aware of the fact that I can control a huge infrastructure that keeps me into the outer space much farther than any human have been. Okay, I don't speak about the astronauts that have flown on the moon, but you have the opportunity to look at your own home planet and to understand that the life it's originated on this planet, and all the normal living processes are happening down there when you can see the planet huge but have a surface of about, or a diameter of about 4,000 kilometers. You look from the altitude of the that you are a strong being, not a strong person because you are the representative of the human beings, a strong being up there, in the same time very vulnerable, because you can be hit by anything into the outer space, by a space debris, by a meteorite, and you may disappear in the same time, very fast. So you have two feelings you don't have on the ground. This mixing of the two feelings of the strongness of the human being and the vulnerability of the human being, it gives you a special feeling being up there. From the ethical point of view, you think that being up there, you can destroy the earth. You may have guns, you may have weapons to act against anybody on the ground, but in the same time, you think that you have to protect the planet, to protect the humanity, to protect individuals on the ground. You should have this feeling. Of course, some bad people that are doing wars could fly into the outer space, could have such not ethical thinking about the planet and about the people. Of course, in the future, the world will move to the outer space. So the weaponization of the outer space happens even now, but military actions were not yet taken. And the balance between big powers, especially between the US, Russia, and China now, but in the future of Japan, India, the European Union, the balance between these countries and the diplomatic relations will stop the utilization of the outer space for military purposes, for the wars and attacks from the outer space. All these things have a very ethical charge in them. In the same time, the protection of the humans into the outer space is also an ethical problem. You have to build the spacecrafts and to build the space stations such way that they ensure not 100% of protection for the astronauts, but at least 98%, and it's calculated now for the habitable environments into the outer space. In the same time, a few years ago, it was developed program for private persons to fly on Mars. Mars One was the name of a foundation from Netherlands that sold slots for persons to fly on Mars in the future and to stay there. They didn't ensure the recovery of the person and to bring them back to the ground. So it was first a non-ethical program because you have to give the humans anytime the possibility to come back and to save their lives. So the ethical problems are discussed also in the framework of the United Nations, not only for space flights, but for a lot of other activities on Earth. And I consider they are very necessary, very necessary.
Thank you.
Okay, welcome. So we still have 10 minutes?
We have 10 minutes, yes.
Okay,
There
let's
are
answer some
a
other
few
questions.
From YouTube. Again. Yeah, here it says from Anna Olympia, special greetings, Dorin. My questions, first question, among the 22 research topics you had to do on board the station, which of them did you encounter the greatest difficulties with? Second question, what is your relationship with green onion?
So scientific experiments first?
First, yes, please.
So my scientific experiments. So actually I accomplished on behalf of my country and on behalf of the international community taking part in the Intercosmos program, 22 scientific experiments. Some of them, they were medical experiments. Every day, twice, I have on me, on my head, on my body, a lot of sensors that measures all my parameters of the body. And they were sent to Earth through telemetry and analyzed by medical doctors that made the research on myself, how I did accommodate to the weightlessness, how was the period when I was already accommodated, and they continued the measurements when I came back, how was my accommodation to the Earth conditions. Same time, we had some psychological experiments, psychological to determine our capacity of work, our capacity of making calculations, mathematical calculations, about the fatigue installed in the human body in the first days after the space flight. And such parameters of measuring the capacity of the body to adapt and of our psychic to adapt normally to the weightlessness. We had some technological experiments to grow crystals into the outer space, some experiments to determine the space radiation, including the measurement, live measurement of the space radiation in different regions of the Earth, above the Earth. And it was established that above the Southern Atlantic Ocean and the Brazil and that region, the space radiation grows pretty fast because there are some anomalies in the magnetic lines of the Earth. Maybe in the underground there are some reserves of metal that change a little bit the magnetic field of the Earth. And my measurements demonstrate that in that area, the space radiation on board the space station is 20 times more than usually in other places above the Earth. And I had a small device that measured the radiation, show me the level of the radiation, and I notice during every 15 seconds the level of the radiation. And the scientist could establish a curve of the modification of the radiation in that area. Also, I have some experiments. An experiment, Astro was the name of the experiments, to determine the different type of very charged, energetically charged particles that hit the space station outside. We just put a special sensor outside that had actually two sensors. They move against each other and they move one full movement in one tour around the Earth. And the energetical ions, particles outside the space station just hit the sensor, made a small hole in the two parts of the sensor. Then we brought back to the Earth the sensor and determined in what part of the Earth, what hole was done, when they coincide, and what type of particle was heated hit actually the sensor. So such type of experiments. And the second part of the question? It had two parts.
What is your relationship with green onions after spaceflight?
Ah, okay. Somebody read something about these onions. Sure, it's not an anecdote, but you know, there are a lot of unofficial things happening into the outer space sometimes. Vladimir Kovalyonok was the commander of the main crew. He spent into the outer space several months. He was already into the outer space from 2 months when I flew into space. And his wife was very demanding woman, like a general with a higher rank than most of us. She asked the doctor of the crew, of our crew, to bring to the outer space some fresh onion, green onion, for Volodya, for Vladimir Kovalyonok, because he very much liked to eat green onion. And we didn't know anything about all these things. And the doctor of the crew, who accompanied the crew till the rocket, when we were in the bus, only we two and he took from this medical suit, medical stuff, newspaper, and in the newspaper was this onion. He just gave it to us, take it and take on board the space station because Vladimir Kovalyonok wants to eat this onion. We're amazed what to do with this onion. And Popov decided to give me the chance to take the onion up there. We had 4 pockets on our legs, 2 pockets for gloves and 2 pockets for different other equipment just in case. And in one of that pocket, I put the onion. Nobody have seen it. And I took it to outer space and give it to Kovalyonok. He enjoyed very much eating green onion took by us to the outer space. That was my relation with green onion into the outer space.
We have one more question.
Oh, Anna Olympia, special greetings. Okay, thank you very much. We know each other. Encounter the greatest difficulties and why. So I already explained about the experiments did into the outer space. I just wanted to greet Anna Olympia. She lives in Italy now. But she wrote some things about my space flight some times ago and some stories. Okay, the last question, Sandra, read it.
Okay, we have one last question.
Okay.
I
have time for one last question if you have one.
The first one. The first one.
So how did this mission, so from Valentina Radik, how did this mission affect you on a personal level after you came back from the space? It's a good one to answer?
Yes, it's a good one. I haven't seen that one. Thank you.
Or if you want a different one?
No, thank you. That's a good one. I haven't seen this one. Thank you, Dorin.
Okay, I have it on the chat. I can tell you that the space mission completely changed my life. First, during my training, my final goal was just the space flight. I was married, I had 2 children. Before starting the training for the outer space, I worked in the factory as an airspace engineer, aviation engineer, building airplanes, taking part in the construction of them. And I thought in my, I could say, naivety, that after my space flight, I just come back home, I go to the same factory and I continue my work as an engineer. I never thought that it will really change my life. After I came back from the outer space, saw the journalists just jump on us and ask a lot of questions every day. And it was pretty difficult for me to accommodate to all these new lifestyle. As a public person, I have to change my habits, everyday habits. I have to face a lot of interaction, public interaction I was not used to before my space flight. I had to have a lot of public speeches, conferences anywhere in the country, somewhere in the world. I had to learn English because till then I learned in the school French and German, and then I learned Russian. I did it, and now most of my conferences are in English, if not in Romanian or Russian. And of course, the relations in my family change a lot because I stay at home a very few times, and my wife was obliged to take care of the children much more than before when we share all this obligation in the house. She was a little bit sorry for me because I was obliged to do a lot of things I didn't before and to spend too much time from her point of view for my professional activity than I spent before, and to stay at home sometimes just a few hours a week and then travel a lot. It's not anymore the case now. I travel a lot now. Before the pandemic, I travel a lot, but sometimes I took her with me because she's a retired person from the Ministry of Foreign Affairs. And now our children are grown up. Our sons are 45 and 43 years old. We have grandchildren. And now we have the opportunity to travel by our own without taking care of the house. We just lock it and leave without taking care of children because they have their own houses. But was not exactly the situation when I was very active from a professional point of view.
Dorin, thank you very much.
Okay,
You
welcome.
are the best.
Oh, thank you very much.
Thank you for joining us again today, and I hope we have the pleasure to meet soon in real again.
Yeah, I hope so. I hope so. I love very much Vienna. I spent there many weeks every year. I'm part of the Romanian delegation to the UN Committee on the Peaceful Uses of Outer Space. This committee is located in Vienna from 1993. So I come to Vienna from 1993 every year, twice a year at least. Now I'm the vice chair of the working group on Space Agenda 2030 of this committee. And we have to finish the work on this agenda, but it could be done by meeting, by negotiating live. And it's pity that we don't have the possibility now to travel. But I hope for the best for the next year. The vaccine is very close to be injected to most of the population. And I hope we'll finish with this pandemic in no more than 1 year. Thank you very much once again. Greetings. Happy holidays in the future because we are always in December. And maybe we'll see each other somehow, if not online, live. Sandra, thank you very much once again and keep in touch.
Thank you very much. Bye-bye. Bye.
Thank
Bye.
you so much.